So today we're going to look at how you would actually evaluate a log when you can't get the numbers to be in the same base. So change of base formula lets us actually type a log into the calculator because the calculator does not allow you to use the little base part of the exponent. The calculator only allows you to put in logs that are base 10 into the calculator. So in order to put in logs that have bases other than 10, we have to use the change of base formula. If I wanted to evaluate the first one, we already know that log base 4 of 16 is asking us how many 4s do we have to multiply in order to get 16, right? Or if I was going to rewrite that in exponential, I would say 4 to some power equals 16. And we could actually evaluate that without using a calculator, right? Because we know 4 squared is 16. So log base 4 of 16 really equals 2. But if I was asking you to evaluate log base 4 of 9, if I said 4 to what power equals 9, that we don't know off the top of our head, right? It's not a pretty number. So in order for us to evaluate these, we're going to need the change of base formula so that we can plug it into a calculator and get that decimal out. If for some reason, your dog eats your notebook or you're trying to do your homework while you're at the grocery store or something and you don't have your notebook and you need to reference any of these log rules, they too are linked on that second slide of every virtual classroom. All of the log properties are up there for you. So, change of base formula tells us that if we have log, we'll call base B of x, and we want to type it into our calculator, it's the same thing as saying log of x divided by log of b, where we no longer have a base for the log. When we don't have a base written there, it's just assumed that it's a 10. So the calculator is programmed to use logs base 10. So in order for us to put it in the calculator, we've got to use log base 10 because that's the only button that we have on our calculator to actually push. So you're going to take the log of the big number that's inside the log divided by the log of the base. So the base stays on the bottom. So if we were going to evaluate the logs below using the change of base formula, all I'm going to do, is the 5 is going to stay on top, the 2 is going to be the one on the bottom. So I would type into my calculator log of 5, and I want to make sure I close the parentheses, divided by log of 2, and that's going to spit out a decimal for me. You can do it on Desmos too. If you're using Desmos, if you don't actually have a calculator, I would definitely use Desmos over your phone calculator, because your phone calculator can get a little hairy if you push the wrong button too many times. If you're using Desmos, you can literally type in LOG and the number, and it recognizes LOG as a log. So can anyone tell me what log of 5 divided by log of 2 is? What do we get? 2.5. Do we agree? You're just taking a stab in the dark?
I got 2.3.
2.3. 2.3? Beautiful. 2.3. Now, if I have log base 2 of 10 to the third, this 10 to the third is all going to stay together. The 2 is going on the bottom. So now I'm going to have log of 10 to the third divided by log of 2.
9.965.
Round to 10, give me at
9.965.
9.965.
I think it'd be 5 around that. 7.
Because it's 7 afterwards. Once we get to 3 decimal places, you can either round it or you can just cut it off. Because once we have 3 decimal places, we can say that's accurate enough to where if we had to round it up or keep it the same, we're okay with either of those.